Good day, grade 12s, and welcome to Learn Extra Geography for grade 12. And we will be starting these next couple of sessions with river systems, which is the beginning of geomorphology. We will look at different features, go through different drainage patterns, and put them all together in a nice section, followed shortly afterwards by a set of answers and questions that will be very helpful for your final exams. Our first thing that we are going to look at, the key concepts for this first section. We will look at where the water in our rivers actually has come from, how did it get there. Secondly, the factors that influence runoff. Just a reminder, grade 12s, that when we refer to the word runoff, we are looking at how much water is moving across the surface of the earth. We're looking at infiltration, which is the water that seeps in below the level of the earth's surface, and the rate of erosion, which is the main job of water in terms of rivers on the earth's surface. And lastly, we will be looking at our different drainage basins that form as a result of a variety of different river patterns. So those are the key concepts that will be covered in this first river systems session, and then we will look at other sessions to come. Right, so the first part of the session that we are going to look at is essentially where does the water in our rivers actually come from. We know that the water exists, we know that our world is covered by water sources, and just a reminder that the water that flows within our rivers is predominantly fresh water, which is of vital importance. So the two main things that we are going to look at is, number one, we are going to look at surface runoff and direct runoff. Now, surface runoff or direct runoff is the actual water that flows across the surface of the earth after rainfall or precipitation has occurred. In the notes, it says that sheet flow and stream flow after precipitation, it refers to meteoric water. Meteoric water is water that has come from the atmosphere above us in terms of climate. That water is found in the form of rainfall. It could be snow, it could be hail. So, surface runoff, just a reminder, is water that is actually found on top of the surface of the earth that we can see. Secondly, other water that has found on the earth's surface, it could be in the form of what we term groundwater or base flow. Another term for these two names would be what we call indirect runoff. Okay, and obviously indirect runoff would be the opposite of runoff. Okay, so indirect runoff, direct runoff are the two forms of runoff that we have on the Earth's surface. Groundwater, base flow, all types of indirect runoff. In the notes, it says infiltrated water, water that is sunk below the Earth's surface, that is first stored as groundwater and later eventually seeps into the actual river channels. This is supplemented with juvenile water and fossil water in some regions of the earth. Very nicely, we have a diagram which represents the hydrological cycle. What you should know about the hydrological cycle, grade 12s, is that the hydrological cycle is actually considered to be a closed system. What that means is that no water can be added to the system or taken out of the system. All water on the Earth's surface is somewhere within the cycle at every single minute of the day. So if we look at the actual cycle, you will notice above our oceans, which is our main source of evaporation. Evaporation, just a reminder as to what's happening at that process. Evaporation is where we take the liquid water from the ocean and we convert it into water in its gaseous form. That is the process of evaporation, liquid water to gaseous water. From evaporation in the upper atmosphere, there will be particles or what we call nuclei that the water will actually condense onto. So condensation is the opposite to evaporation, where condensation, we take water that is found in the gaseous form and change it back to water in the liquid form. In order for that to happen, there has to be some or other surface within the upper atmosphere on which particle or water can actually condense. From condensation, we have the formation of clouds, and clouds leads to precipitation. Precipitation can be in a variety of different forms. We could have the most obvious one, which would be rainfall. Snow is another form of precipitation, hail, fog, dew, though any sort of water that comes from the upper atmosphere down towards the surface of the earth is considered to be precipitation. What you will notice then is that over here there's the word percolation. Okay, percolation is just another way of saying infiltration. You will notice that the arrow is actually showing you that the water is seeping below the Earth's surface. Right, once the water has percolated below the Earth's surface, it becomes a part of our groundwater, which actually ends up in our water table. On the top part of the diagram, which is the actual surface of the earth, you will see that it refers to surface runoff. Okay? Surface runoff would be these actual rivers. Let's just change the color. Okay? We'll go to pink here. You will notice that these rivers are actually flowing down towards the ocean. Okay? Whenever the water is within a river channel or just flowing over the Earth's surface into those river channels, it is referred to as surface runoff. The last word on this diagram that we have neglected to explain is this word transpiration. Now, transpiration refers to taking water through heat out of plants. So it's very similar to evaporation. You're taking liquid water and you're changing it into water in the gaseous form, but that water that is being absorbed through the heat or evaporated through the heat comes actually out of the leaves of plants and other types of vegetation. In the left-hand side of the diagram here, you will see that 87% of the Earth's water is actually composed in our oceans, and very importantly, this water over here is extremely salty, okay, which means it cannot be used successfully in terms of what we need it for on Earth. 9% of the Earth's water is trapped in the glaciers, which means it's solid ice. Underground rivers and lakes and rivers combined together only gives us 4% of the natural fresh water found on the Earth's surface. So the hydrological cycle is a very, very important cycle that we need to understand in order for us to understand the concepts of rivers, which follows after this section. So it's very important that you know each definition of all these words that are found within the hydrological cycle. Just to revise, evaporation is where we take liquid water and we convert it into water in its gaseous form. Condensation is taking water in its gaseous form and turning it into liquid water, followed by precipitation, which is the process of water coming down from the atmosphere towards the surface of the earth. Percolation is another name for infiltration. Infiltration is water that seeps below the earth's surface. Groundwater is the water that flows underneath the earth's surface. Transpiration is changing once again liquid water into gaseous water coming from vegetation. And lastly, surface runoff is water that is found on top of the Earth's surface. So please make a very important and conscious decision to learn this water table. All right, moving on. Now that we have discovered exactly where the water that lands on our Earth's surface is coming from, we need to now look at those factors that are going to influence the amount of runoff. In other words, what sort of things are going to control if there's going to be a lot of water on the Earth's surface, or what things will make it there be less water on the Earth's surface. And we're going to look at what influences infiltration. So what will cause the water to sink in below the Earth's surface towards our groundwater. And lastly, we will look at the rate of erosion. So the first factor that we are going to look at is what we refer to as our precipitation. I've already explained that precipitation is any moisture that is coming out of the Earth's atmosphere towards the surface of the Earth. First of all, if our rain is nice and soft and gentle, it's going to encourage more infiltration. Okay, so the rain is occurring, it's very soft, very gentle, it's got time to hit the Earth's surface and infiltrate below the ground. As opposed to hard rain or rain that comes from a thunderstorm, that is going to give us less infiltration into the Earth's surface. So soft, gentle, soaking rain will seep below the soil and end up in the water table, whereas hard thunderstorm precipitation is going to have no time in which to infiltrate and therefore cause less infiltration. Furthermore, winter rain, obviously when we experience our winter rain, and this is now predominantly for the Gauteng region as opposed to the Western Cape that receives a winter rain. So when we receive our winter rain up here in Gauteng, we're going to have much less evaporation. The reason, grade 12s, that we have that less evaporation is because the sun's heat during winter is not as strong as the sun's heat during summer. Because there will be less evaporation, there's obviously going to be more infiltration. So it's going to have time to sink below the Earth's surface and not get evaporated immediately. As opposed to summer, during our summer, our temperatures are exceptionally high. That evaporation will take place a lot quicker, resulting in less infiltration. So with precipitation, there's a couple of factors that you need to look at. With precipitation, soft, gentle, soaking rain encourages more infiltration, and hard, fast thunderstorm rain encourages less infiltration. Furthermore, winter rainfall will not be evaporated due to the low temperatures of the sun, and therefore encourages more infiltration. Summer rain, more evaporation because it's nice and warm, and less infiltration will take place. Secondly, we are going to look at our soil moisture content. When we speak about soil moisture content, we are literally looking at how much liquid is found within the soil. So it says on the slide, if the soil is already saturated, saturated means that that soil has got too much water in it, that no more water can be absorbed into that soil. So if we talk about saturated soil, that soil is holding all the moisture that it can possibly hold for that period of time, and therefore if more rain is to hit the surface of saturated soil, it is going to encourage runoff to take place. So it says if soil is already saturated with water, there will be little infiltration, and you need to start learning that if we have less infiltration, there will be more runoff. So the less water that infiltrates, the more water there will be on top of the Earth's surface. Thirdly, if we look at vegetation, vegetation is a wonderful thing in terms of runoff moving across the Earth's surface. Dense vegetation. Dense means lots. Okay, so if we've got lots of vegetation on the Earth's surface, it enhances or encourages infiltration. What that means is that the water will slow down the water that moves across the Earth's surface, cause it to stop. The minute that water stops, it has time to seep below the level of the Earth's surface. Well, sparse vegetation, this word sparse, okay, ultimately means zero vegetation. or little vegetation, okay? So sparse vegetation implies there isn't any plants in the area, or if there are plants, there's very few of them. Because of that, it leads to more runoff and obviously then less infiltration into the ground. The more runoff we have, the quicker that water will move across the Earth's surface, and therefore it will not have time to sink below the Earth's surface. If we look now at the gradient of the slope, okay, when we talk about gradient, grade 12s, we're looking at the steepness of the slope. Does it have a steep slope? Has it got a gentle slope? Steep slopes are going to encourage more runoff, which means less infiltration. Okay, so we're just going to abbreviate here so that it all fits in. But basically, if we're having more runoff, we're going to have less infiltration. And gradual slopes, another name for gradual grade 12s, we refer to gentle slopes. Okay, gentle slopes enhance infiltration, which means then that there is less runoff. Okay, so if we're encouraging the water to sink below the Earth's surface, therefore there will be less runoff on top of the Earth's surface. So steep slopes will encourage more runoff, less infiltration, and gentle slopes encourage less and gradual slopes encourage less runoff because the water has time to sink below the surface of the Earth. If we look at porosity, okay, porous rocks allow more infiltration and reduce runoff in that area. Okay, the reason being, when we refer grade 12s to a porous rock, we are looking at rocks that have got spaces between those rocks that allows water to seep into it. Often associated with porous rocks are what we call permeable rocks. Now, permeable rocks allow for more infiltration, which once again will result in less infiltration, in less runoff on the Earth's surface. So what you need to remember from this very important section, which is the factors influencing runoff and infiltration, is what the different factors are, and more importantly, what effect are they going to have on the runoff, and ultimately, if they're affecting the runoff, how does that affect infiltration? Always, if we are going to have a high amount of runoff, we will have less infiltration. If we have less runoff, we will have more infiltration. Okay. All right. Now we're going to look at drainage basins and the important concepts that you need to know around a drainage basin. Starting with, I believe, the most important is a definition of what is a drainage basin. And literally speaking, a drainage basin is the area from which the main river and all of its tributaries will obtain its water. If we look at the diagram on the screen, I'm going to highlight the drainage basin for you. Okay, so this dotted perimeter over here, as I run my pen through it, okay, all the way around, coming this side. The area that is found within that green boundary is what I refer to as my drainage basin. You will notice that this stream over here in pink is my main stream of that drainage basin, okay? And the following in yellow are what we call the tributaries to that stream, okay? So the drainage basin is the area that is drained by the main river and all of its tributaries. Okay. Underneath are the important words that we need to understand. Now, the first important word, and I'm going to show you where they are within the diagram, is the mainstream. Okay, so we have already identified our mainstream, which would be this pink stream starting in these areas over here. Okay, and flowing down towards our exit point on the western side of the map. This would be the west, and that's what I would consider the eastern point of our map. Secondly, it refers to the mouth of your river. The mouth of the river, grade 12s, is the point at which that river, which is over here, is possibly going to enter into the sea. So the exact point where the river flows into the ocean is the mouth of your river. A tributary are any smaller little streams that enter into or form a part of the main river. The job of a tributary is to add additional water into that main river system. Number C is the watershed. Now, grade 12s, the watershed is very importantly always a high-lying area that separates two different drainage basins. So what you can imagine is that on the outside of this drainage basin, we would have a mountain over here, okay, that would pretty much go around this entire drainage basin. A watershed is a high-lying area that separates one drainage basin from another drainage basin. So on either side, in other words, going this way, we would probably find another drainage basin that looks similar to what is on your screen at the moment. All right. The origin of the stream, okay, that is also referred to as the source of my river. All rivers are or have their sources up in high mountainous regions. A river will flow from a high-lying area to a low-lying area, and in the case of the rivers in South Africa, they start in mountainous areas and they flow towards the oceans on either side of our coastline. Interfluves. Now, just like I said to you, a watershed was an area of high-lying land between different drainage basins. Our interfluves are high pieces of land that are found between our different tributaries. So for example, if we look at the diagram here, I would be able to draw a piece of high-lying land between these two tributaries at the bottom. That would divide the water between those two systems. So an interfluve is a piece of high-lying land found between tributaries. A watershed is a piece of high-lying land dividing two drainage basins. It's very important that in the tests or in the exams, you would be able to differentiate between those two, as it's a nice question that can be asked. Lastly, they speak about the main watershed, okay? The main watershed would be going around this entire drainage basin. Just by looking at it again, I can see that there are a few little watersheds found within the same drainage basin. They have or can be identified by these dotted lines over here. So what you would find is that this would be a piece of high-lying ground that would separate our two areas of the drainage basin. Okay, now moving on, it says drainage basins terms you should know, and this is just a nice slide to show you the different drainage basins that are found across South Africa. And if they take a closer look, we can see that the rivers have been highlighted in blue, and you will notice that these drainage basins go right around. They're not specific to any provinces, okay? For example, you will see KwaZulu-Natal here has got two separate drainage basins within the same province. So it's not dictated by province. This diagram is just showing you different types of drainage basins around our specific rivers. These would ultimately be the main rivers found in South Africa. So, for example, if you just look, let's take the Orange River, which is the longest river in South Africa, you will notice that it has got the largest drainage basin And that's because the longer or bigger a river is, the larger its drainage basin is literally going to be. So the Orange River, which is the longest river in South Africa, has got the largest drainage basin. Right. Okay. Now, drainage basins, we now need to look at the characteristics of our drainage basins, and very importantly we look at a section which is referred to as stream ordering. Now, stream ordering is where we look at a drainage basin and we have to number the streams in terms of whether we think they are first order streams. When two first order streams meet, they become a second order stream. If two second order streams meet, they become a third order stream. And so the process goes on, and there's actually no limit to the order that a drainage basin can actually have. So all origin streams are order 1 streams. So any little river that starts up in a high mountainous area is given a stream order of 1. As I said before, where two similar stream orders meet, it goes to the next order. So if you have two first order streams meeting, it becomes a second order stream. Two second order streams that meet become a third order stream. Now, with our stream ordering, there are a certain amount of rules that you need to remember in terms of these stream orders. The first rule, as stated here, says the higher the order. So a fifth order stream has a higher order than a second order stream. And what they're saying is that the higher the order, the less of those streams there would be in a drainage basin. Ultimately, they're saying the higher the order, the fewer the amount of streams per order. In other words, there will be lots of first order streams and few fifth or sixth order streams. That's the first rule, okay? That rule is basically the law of number of streams. So if we had to write it in here, this first rule is the number of streams, okay? Which means, once again, first order streams, lots of first order streams, fourth order streams, maybe 1 or maybe 2. Our second rule, grade 12, says the higher the order streams, the longer the stream will actually be, okay? So first order streams will be very short, fourth order streams are going to be very long. If we had to abbreviate, right, this would be the length of streams, the rule that applies to the length of streams. So to recap, a first order stream would be a very short stream, whereas a fourth order stream would be a very long stream. Then we need to look at gradient, okay? First order streams, because they are found up in their high mountainous areas, they are going to have very steep gradients. Fourth order streams, found very low down, have got a very gentle gradient. So if we abbreviate this one, we are just going to call it the gradient rule. Okay, first order streams, steep gradient, fourth order streams, gentle gradients. And our last rule is the size of the drainage basins. If I am to draw a drainage basin around a first order stream, it's going to be a much smaller drainage basin than if I draw a stream, if I draw a drainage basin around a fourth order stream. So this last rule is the rule that relates to the area of the drainage basin. Okay. All right, so we've got 4 rules that we need to remember. The first one is the rule dealing with the number of streams found within that drainage basin. The second rule is the length of the streams found within the drainage basin. The third rule is the gradient depending on the number of streams. And the last rule is the area of the drainage basin. Now we have a nice diagram in which I can show you some of these rules that we have just discussed. So what you see in front of you is we have a main stream and we've got some of its tributaries. Just to show you how to order a stream, you will notice that all these beginning streams over here have been labeled with the number 1. Okay, so we've got a first order stream over there that meets a second first order stream, and what you'll then notice is that the stream ordering goes to the next level, which is a second order stream. At this point, you will see that a second order stream is meeting another second order stream, and so the stream order changes to a third order stream. If a lower order stream meets a higher order stream, the stream will retain the higher order. So for example, at this point over here, a second order stream is meeting a fourth order stream, and therefore the fourth order stream will dominate and the stream ordering will remain a fourth order stream. Okay, going back to our rules, if I were to count the number of first order streams on this diagram, you will see we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. We have got 12 first order streams. Okay, if I were to count the next batch, we've got 1, 2, 3, 4. We have 5 second order streams. You will already notice that the number of streams is decreasing. If I were to count my third order streams, 1, we have got 2 third order streams, and obviously we only have 1 fourth order streams. So going back to our first rule, where it says number of streams, you will notice now that we have just proved that rule, that there are more first order streams than there are fourth order streams. Okay, our second rule was to look at the length of those streams. So if we just go over to our map, there is a first order stream, okay? And if we compare that to the length of a second order stream, there would be my entire second order stream, okay? Obviously the length is much shorter. Our third one, we can't really see the gradient on this particular diagram, but just be advised that first order streams are found in the high mountainous areas, so that they do have a much steeper gradient. Lastly, I can show you the size of the drainage basins. If I were to draw a drainage basin around this first order stream, there it is, okay? As opposed to drawing it around a second order stream, you will see that the size of a drainage basin around a second order stream is much larger than the drainage basin around my first order stream. Very, very important to learn the rules of stream ordering, and very much so in order to number the streams within a drainage basin. Okay. Right, now we need to look at the characteristics of any particular drainage basin. They're going to be very different. It might depend on what part of the country they're found in. It may depend on how much rainfall that drainage basin receives, and therefore it's going to result in different amounts of water being on the surface at any one time. So in terms of the most important characteristic of our drainage basins is we need to understand what is meant by this term drainage density. Okay, density, we're looking at the amount of water on the Earth's surface. So the definition, and you must learn your definition for drainage density, is the total length of all the streams in a drainage basin divided by the drainage basin area. Okay, so when we look at our drainage density, we take into account the entire length of all those streams within the drainage basin, and we divide it by the drainage basin's area. Okay, It's very important to know that definition. Right. In terms of that drainage density, we can speak about 3 different levels. We either have a fine drainage density, a medium drainage density, or a coarse drainage density. If we talk about our drainage density being fine, it means grade 12s that there are many streams within that particular area. So if you can picture a drainage basin, there's going to be a lot of different streams on that drainage basin. A medium drainage density, there would be an average amount of streams, and obviously coarse drainage density would have few streams for a certain area. Okay, now our factors that influence our drainage density are very similar to our factors that influence infiltration and runoff, because obviously, like I said, with drainage density we are looking at how much water is found on the surface of the earth at any one time, and that's going to be impacted by how much water will infiltrate or how much water is going to run across the Earth's surface. So our first factor that we're going to look at that will influence our drainage density, once again, is precipitation. And what we need to know here is the more precipitation we have, we're going to have more streams found on the Earth's surface, which is going to give us a higher drainage density. Okay, with a gradient, steeper gradients once again cause the water to run off the Earth's surface faster, and therefore there will be less surface streams found on top of the Earth's surface. Vegetation, dense vegetation causes more infiltration, and therefore there will be less streams on the surface of the Earth. If there are less streams on the surface of the Earth, it's going to give us a coarse drainage density. Permeability and porosity. A rock that is porous and permeable allows for more infiltration and less surface streams will develop, once again resulting in a coarse drainage density. So you will see, grade 12s, that the factors that influence our drainage density are very similar and often asked within the same question as our factors influencing infiltration as well as runoff. All right, moving on. If we look at our drainage density, we've got a slide now that will show you a low drainage density for a certain area. This particular area is an area near Olifantshoek, Sishen and Kuruman. It is found in the Northern Cape, okay? Because it's in the Northern Cape, what you should remember is that South Africa's rainfall decreases from our east coast towards our west coast, which therefore results in fewer streams being found within that area. And that is why this gives us an example of a low drainage density. Low drainage density implies that there is less water moving across the surface of the earth. As opposed to a high drainage density diagram, this picture that you are now looking at comes from the east coast of South Africa, which receives a maximum amount of rainfall for South Africa. And you will notice that there are many different streams found on that actual diagram, which gives us an exceptionally high or fine drainage density. Okay, right. Now, going back to our drainage basins, there are certain drainage patterns that result from a variety of different features. More dominantly, we look at the geology or the rock structure below the surface of the earth, which creates different patterns as to where the water will flow within different drainage basins. You need to be able to identify these patterns and say why a specific pattern has formed. So the first one we're going to look at is drainage patterns refers to the shape of the river system that is caused by the underlying rock. So when we're looking for patterns, we are looking at the shape of the river system, and it's as a result of the underlying rock structures. The first and most common drainage pattern is what we call a dendritic pattern. Now, with this pattern, it's one of the most easiest patterns to identify because it looks like the branches growing on a tree. So that is ultimately what a dendritic pattern looks like, and it is very easy to spot. Very importantly, a dendritic pattern has resulted because it formed on rocks that are uniformly resistant to erosion. In other words, grade 12s, one part of the rock will not erode quicker than another part of the rock. They will all erode and weather at the same rate. Tributaries join at more obtuse angles on steeper slopes, and a dendritic pattern in the Karoo. These are tributaries in the upper regions of the Horit River. If you just look at the diagram on the screen, you will see that branch sort of nature of a dendritic pattern that develops. So very importantly, you must be able to identify a dendritic pattern, and if they ask you to give a reason why a dendritic pattern has been found, it's because it develops on rocks that are uniformly resistant to erosion. Our next pattern that we are going to look at is what we call a rectangular pattern. Now, with a rectangular pattern, very importantly, in order to identify a rectangular pattern, the main stream and its tributaries have got 90-degree angles in them. And the reason this occurs is because a rectangular pattern forms on rocks that are exceptionally well jointed, which means that the water will flow in the joints of the rock, and that is where our drainage pattern will develop from. So if we look at the diagram on the screen, you will see that these rivers are entering the mainstream at a 90-degree angle, and furthermore, the actual tributaries are making 90-degree turns within themselves. So for a rectangular pattern, in order to identify it in a diagram, you need to look as to whether those tributaries are making 90-degree angles, and when the tributary enters the mainstream, is it making a 90-degree angle. Furthermore, if you were asked to give a reason, a rectangular drainage pattern will form on igneous rocks that are well jointed. Okay, our third pattern is what we call a trellis pattern. Now, trellis patterns and rectangular patterns can become quite confusing, but very importantly, they are found on different underlying rock structures, and that's what gives them their difference. So with our trellis patterns, we have got tributaries that will join the stream at approximately right angles. So just like the rectangular pattern, they will also join at a 90-degree angle. And so these have got them too. The only difference is that in a trellis pattern, there will not be 90-degree angles within the actual tributaries. They develop in fold mountains, homocliner ridges, and very importantly, what we're looking for here is alternating layers of hard and soft rock. Our rivers will erode the softer rock before they erode the hard rock. A trellis pattern is shown below within this diagram. Okay, so you will see that these streams are entering once again at a 90-degree angle. It's a very different shape to a rectangular pattern, and if you're asked to give the underlying rock structure, it needs to be alternating layers of hard and soft rock that has undergone some form of folding. Okay, our fourth type of pattern is what we call a radial or centrifugal pattern. Now, very importantly for radial patterns, the streams run outwards from a high point. So if you can imagine, we have a dome-shaped figure and there's precipitation happening on top. The water is going to run down and away from that high point. So radial is found on a high piece of land, and more often than not, we find radial patterns on dome-shaped features. So if you're given a dome, which you look at a lot later on in the structural component of geomorphology, you will find a radial drainage pattern on that particular structure. If we look at the diagram that has been given to us, you will see that although it's a flat piece of paper, you need to imagine that this part over here is essentially a high point, and all these rivers are running down away from that point, creating that radial drainage pattern. Right, our last pattern is what we call a deranged pattern. Okay, now the word deranged just implies that there is no clear pattern visible and these streams are just at various points within the geology. It develops on flat areas, okay, that have had previously a glacier on them. I can tell you now that a deranged pattern is not asked as commonly as your dendritic, trellis or radial patterns that we have previously discussed. Just looking here at the diagram, you will notice that this deranged pattern has got absolutely no sense to it. There's just arbitrary streams in the middle of nowhere. All right, so that brings us to the end of the theory section in terms of this first session on geomorphology. Couple of things that are very, very important for you to remember is you need to understand how different factors will influence our runoff, our infiltration, and obviously our drainage density, which we looked at. You need to be able to identify different patterns that form within the drainage basin and give reasons as to why a particular pattern has formed. I pointed out earlier that dendritic, trellis, and radial are the three most common types of drainage patterns that are tested. Secondly, it's very important to be able to order your drainage basin in terms of the streams that are found within it and learn the 4 rules that govern those stream ordering. The first one being the number of streams, the second one being the gradient. We need to look at the length of the streams, and we need to focus on the area of those drainage basins. But stay tuned, we are just going to cut to a quick break, and after the break we will be back with a set of questions and answers that you should be giving for these questions to help you through this particular section. See you after the break. Welcome back, grade 12s, and I hope that you managed to learn something from the theory section. We are now going to look at some previous past paper questions, and we're going to go through the answers and how you should actually be attempting these questions and what sort of answers they are looking for. So our first question we're going to look at is at the start of all geomorphology sections. They give us these easy true or false questions, match the columns, things like that, which are easy marks to get, and you just simply write down a term or two. So the first one that we are going to look at is question 1.1.1, and we are looking for true or false answers over here. The first question says, an aquifer is a rock that is impermeable and does not allow water to move through it. Now, an aquifer is actually a permeable rock and does allow a whole lot of water to move through it. So this first question is actually false. Okay, so an aquifer is permeable. The word permeable implies that it allows water to move through that rock structure. Our second question is a flow hydrograph. Now, previously in terms of the work that we studied, we didn't really look at flow hydrographs, but that comes a lot later on in a second additional session, but essentially when they refer to a flow hydrograph, we're looking at a graph that records the discharge of water within a river. So the question here says a flow hydrograph records how much water passes a given point in a given period of time, and therefore we know that that answer is going to be true. Okay, so we're looking at how much water moves within that river channel within a certain length of time. Our third question, 1.1.3, a periodic river is a river that only flows in the rainy seasons when it receives groundwater. The answer to that is also true. A periodic river can also be referred to as a non-perennial river. Okay, so a non-perennial river and a periodic river are the same thing. They only flow during the rainy seasons. So for example, in the Western Cape, they will have periodic rivers that will only flow during the winter months. In Gauteng, we've got rivers that will only flow during our summer months because they are periodic and depend on the season. 1.1.4, rocks that are uniformly resistant to erosion and exposed to the same type of weathering will weather at different rates. And the answer to that is false. Rocks that are uniformly resistant weather at the same rate even if they're exposed to different types of weathering. Lastly, 1.1.5, the water table indicates the level of water on the surface of the earth, and that is false as well because the water table is found below the surface of the earth. So those are what we call our relatively easy questions to start off the section with. You will notice that the mark allocation here in the bottom right hand corner is you receive 2 marks for every true or false answer. So that is why it is nice and easy to get marks for these easy questions. And these easy questions are predominantly based on factual knowledge that you can study. All right, moving on. Now, question number 2, it asks us to refer to the extract on the following page, as well as the photograph and diagram of the rivers draining into the Hartbeespoort Dam. So here at grade 12s, we've got a number of different sources that you need to make use of. And very importantly, a lot of the questions that come after reading and going through these sources, a lot of the answers are found within those sources. So instead of just rushing to answer the questions, take the time to read the source, highlight what you believe to be important. The following article is based on the 100,000 lives that are at risk. And it starts by saying, in the summer rainfall regions, the lives of some 100,000 people are at risk. They are in danger because they live in flood-prone areas. Remember, a flood is an excess amount of water that does not stay within the river channel and instead, it overflows its banks and can cause danger to many people. One of these areas with 6,000 residents is an informal settlement below the banks of the Yaks-Gay River within the Alexandra Township, north of Johannesburg. Residents have been warned many times about the dangers of building along the banks. So these people of this residence are living along the banks of this river, which is obviously going to be very dangerous in terms of flood conditions. But they stay there because there is nowhere else for them to go. Hundreds of shacks on the riverbanks have been washed away in the past, yet residents remain undaunted and return to build there predominantly because, as said earlier, they've got nowhere else to go. This figure shows the Yaks-Gay River and other rivers that drain into the Hartbeespoort Dam. The Yaks-Gay River carries heavily polluted water into the dam. The sources of the pollution, okay, so let's highlight the sources: sewage, domestic waste, detergents that reach the river from Alexandria. A lot of these people who live in informal settlements, they use the river for their daily needs, for hygiene, for cleaning their pots, cleaning their clothes, that kind of thing, which adds a lot of pollution. They also receive effluent, which is pollution that comes from our mining areas and industrial waste from the Calvin Power Station. There are also many sewage works along the river that will ultimately end up flowing into the dam. Heavy rains in 1999, 2000 and 2001 have caused the loss of life, so that's what heavy rains have done. They destroy the houses along the Yukskay River. Building on the floodplain so close to the river is a problem. That's what the word hazardous means. As the Yukskay River rises north of Alexandria, rainwater does not infiltrate. Okay, so infiltrate is obviously an important word because this is the section that we are dealing with. Due to impermeable surfaces. Impermeable does not allow the water to infiltrate. And these impermeable artificial surfaces come from the built-up area. Overland flow occurs, and as a result, there's a short lag time and a high flood peak in the rivers as it flows through the townships, which then adds to further flooding caused in these areas. So that is the article. Below the article, you are given the diagram of that drainage basin. You can see there's a key which shows up built-up areas. So those built-up areas have got our artificial surfaces. The sewage works as they're found along the way towards the Hartbeespoort Dam. All these rivers are flowing northwards towards that Hartbeespoort Dam. So now that we've looked at the two sources, we can look at the questions that they have asked. The first question says, identify the drainage pattern. When you look at the question and they ask about drainage patterns, immediately you should think about dendritic, trellis, radial, rectangular. Those are the patterns that they are looking for. And if we go back and look at the source that's been given to us, okay, you will see that if we look at that, it's definitely going to be a dendritic pattern. You can see that tree-like shape coming out, and therefore our answer here is dendritic. Okay, so all you need to write down there is dendritic, and you receive your 2 marks. Our second question, give one reason for your answer. So why did you identify that? And I've spoken to you before. How did we identify that was dendritic? It's because the streams look like branches of a tree. So that's the reason that you can write down for identifying that as a dendritic pattern. The streams look like branches of a tree. Okay. Then it says, question 2.2. Flooding is common in Alexandria, and what is a flood? Now, a flood is basically a situation that occurs when there is too much water within the river channel and the river overflows its banks. So, to give a definition of flood, there's too much water within the river channel and the river overflows its banks, causing water to occur in areas that it usually doesn't occur in. Okay, number B. Why do people build shacks on the banks of the Yukskay River if the area is threatened by constant flooding? And when we were reading the article previously, it said here that they build along the banks of the river because there is nowhere else for them to go. So that answer for that second question is coming straight out of the text. You just need to be able to read it, and then you can write it down as an answer. So the fact that they have nowhere else to build implies, grade 12s, that there is a shortage of space. And secondly, you could even push the answer to they have an attachment to their area, maybe their families live there, and they are reluctant to move from that specific area. 2.2c, explain why there is a short lag time and a high flood peak as the Yaxkay River flows through Alexandra. Right, just importantly, just a reminder, when we refer to lag time, we are looking at the time that it takes from when it rains to when we see a flood peak on our hydrograph. So for example, if I were to just draw a quick little sketch here, okay, and remember this would be a hydrograph that shows the runoff in a river after rain, and we see that there's the flood peak, okay, and there is basically the lag time from when it rains to where that river reaches its flood peak. So explain why there's a short amount of time from when it rains till when the river reaches its peak as the Yaxkay River flows through Alexandra. And in the article, it spoke about the artificial surfaces within that urban area. Artificial surfaces such as concrete or tar do not allow for infiltration. Because there's no infiltration taking place, there is a lot of runoff on the Earth's surface, and therefore we have a shorter lag time. Secondly, another point that you can write down is because there's no infiltration, more water is going to reach the stream, and that will encourage a much higher flood peak because there hasn't been infiltration along the ray. And any water that flows on an artificial surface will create a short lag time. Very important, if we go to the mark allocation, you will see that they are looking for 3 separate points. So number 1, you could say that the land is covered in artificial surfaces. Number 2, those surfaces do not allow for infiltration. And number 3, therefore, more water reaches the river channel, encouraging a higher flood peak. Okay, moving on. 2.2d. Name any 2 consequences of flooding for the inhabitants of Alexandra. Now, first and foremost, in the article it mentioned, let's just go back so that I can point it out. Okay, if we just look here, it says heavy rains in 1999, 2000, 2001 have caused, number 1, a loss of life, and secondly, a loss of homes. Those are really 2 answers that you could put down for 2 consequences of flooding: loss of life and loss of infrastructure in terms of properties being destroyed. Secondly, you could go even further to say that the personal belongings that were in that house or in that structure got taken away. And if we're really going to push our luck, it's going to cost an economy money to rebuild those homes, that kind of thing. So here we are looking for 2 points, and the mark allocation is actually wrong. They want 2 points for every point you give. It is 2 marks, which would make the final mark allocation 4. Okay. 2.3a. Describe the locations of the sewage works in relation to the rivers shown above. There's the key that is used for the sewage works. There we can see one. There's another one. Okay, they're located all over this map. And previously, as I stated to you, all of these rivers are moving in a northerly direction, which means, grade 12, that all of these sewage works are found downstream of the main rivers, which ultimately means that the sewage will be collected within those rivers and taken down towards the Hartbeespoort Dam. Okay, so if we go back to the question, it says, describe the location of the sewage works. They want 1 point for 2 marks. The sewage works are literally located on the banks of those rivers as they move in their drainage basin. So for 1 mark, the sewage works are located on the banks of the rivers. And second point to that question, what are the consequences of the above for the people living on the banks of the Hartbeespoort Dam? So what is the consequence of having those sewage works located on the banks of the river? Things very importantly come to mind, we are going to contaminate or pollute that water, which is a problem. Diseases may spread because the water is flushing out those sewage works. You're going to have a drop in the land value. No one wants to live next to a dam where they have sewage works running into that dam. The dam will become unsightly, which means it will be unpleasant to look at that dam. So there are a variety of different options that you can give. The mark allocation is looking for 2 different options, and once again the total for that question would be 4. Okay, the last question for this particular diagram and information: state 2 measures that can be introduced by the provincial government to ensure that all the rivers flowing into the Hartbeespoort Dam are free of sewage effluents. Sewage effluents, another word for that would just be pollution. Okay, so what they could do is they could build purification dams along the course of those rivers to purify the water that is coming out of those sewage works. They could relocate the sewage works to another area, so move them. And they could have legislation or laws that could prevent the dumping of raw sewage into those areas. That would be our second question completed. Moving on. Okay, question 3. Use the figure below, which shows the different fluvial processes and characteristics of a drainage basin to assist you. Give one term for each of the descriptions below and write only the term next to the question number. So, once again, we are looking at these one-word answers that are the easy knowledge sort of questions that you can get a lot of marks in. Okay, so what we'll see here is a river within a valley flowing from its source to its mouth. And we've got a lot of labels on the map, and we are now going to have to match these labels to the statements that have been given to us. Number 3.1 says, the area where a river gets its water from. So if you go back and we look at the diagram, we see we've got a drainage basin, we've got catchment area, we've got confluence, tributaries, watershed, meander, and the most important one is what's called the catchment area. That is the area from where a river will get its water from. Okay, so you simply then write down catchment area. Number 2, an area that is drained by a river and its tributaries. When we were doing the notes section for this particular session, I said to you that that refers to what is called a drainage basin. The drainage basin is the area drained by a river and its tributaries. So 3.2's answer is a drainage basin. 3.3, the point where a tributary meets the main stream. Now this word we did not look at previously, but it is on the diagram, and you will see confluence is the word that we are actually looking for here. So the confluence is the point at which 2 rivers will meet. So at any point where 2 rivers are meeting each other, it is referred to as the confluence of that river. Okay. 3.4. The section of a stream from one bank to the other, okay, is what we call the cross profile of that river. And if I were to draw you a cross profile, it's very simple. Okay, you are literally looking at that stream from the one bank to the other, and there would be the water that flows within your stream. Lastly, a high-lying area that will separate 2 drainage basins is our watershed. Okay, so watershed, high-lying area is the key word there. And the answer for 3.5 is therefore a watershed. Moving on. Question 4. Question 4 says, Figure 4a illustrates a drainage basin. Figure 4b shows the 3 river courses associated with a river system. Examine both diagrams carefully. So if we look, this is figure 4a. We can see once again that's the area demarcating the drainage basin. Okay, there's the main stream and its tributaries that flows within that drainage basin, and underneath they have given us 3 different shapes or 3 different cross sections or cross profiles, all right, which is essentially what the river would look like at each stage. Now I'm just going to highlight it over here, but basically R would be found up here in the upper reaches of our river system. Profile S is a lot further down over that point over there, and T is much further towards the mouth of the river, just so that you get an idea of where each section has come from. We're now going to use these sections to answer questions based on the diagram. So the first question, 4.1a says, the drainage basin illustrated in 4a shows a low drainage density. They want to know, what does this mean? Now, when we looked at your drainage density, we want to look at the amount of streams in terms of the area of that drainage basin. So if we've got a low drainage density, you will see that the total length of the streams in this drainage basin are small compared to the area of that drainage basin. So if we look at the question, what does a low drainage density mean? It means that the total combined length of the streams within that drainage basin is small in comparison to the area of that drainage basin. Okay. 4.1b. Give 2 possible reasons why this drainage basin has got a low drainage density. So grade 12, so they're looking for reasons as to why there is less water on the Earth's surface. So ultimately, what has caused infiltration to take place, resulting in less runoff on the Earth's surface? So we've got a variety of different things that may cause this to happen. Okay. For example, if we've got dense vegetation in that area, the vegetation will stop the runoff and cause it to infiltrate. The minute it infiltrates, there's less runoff on the Earth's surface, resulting in a low drainage density. Furthermore, it could be that area could be on a very gentle gradient. If it is on a gentle gradient, the water will be moving very slowly, therefore it will have time to sink below the Earth's surface, resulting once again in less runoff. Furthermore, there could be a very high evaporation rate in that area. If you've got a high evaporation rate, the water will disappear off the Earth's surface before it has time to move as runoff. Some other ideas might be that it's flowing over permeable rock. If you've got permeable rock, it allows the water to infiltrate, once again creating less runoff. So you will see, grade 12, that there are a variety of different answers that you can give. They were specifically looking for 2, so any of those that I mentioned would be good enough. Okay, 4.1c says, explain why the 2 factors that you mentioned in the question above will result in a low drainage density. So I kind of have already, in the first question, we should just list the factors. But I've already explained to you, for example, that if you wrote down vegetation, how is that vegetation going to cause less runoff? And how does it cause less runoff? Because it stops the water, causes more infiltration, and therefore less runoff. We also mentioned the gentle gradient. If it's flowing on a flat surface, it's going slowly, it's got time to infiltrate, therefore less runoff. I spoke about permeable rock. Permeable rock allows for infiltration, therefore less runoff. So you've got to be able to explain all of those factors, which is what is required in question 4.1c. Okay. Right, 4.2a says, identify the three main river courses labeled R, S, and T. So in the beginning, I showed you whereabouts those courses would come from, and this question is now asking us to name them. If we look at letter R, okay, I already pointed out that that occurs in the upper regions of our river. Therefore, it can be called the upper course, the torrent course, or even the youthful course. Those are the names that are associated with diagram R. The most common ones that are used for diagram R are upper course or the youthful stage of my river. Okay, for letter S, S is often referred to as the middle course, or what sometimes can also be referred to as the mature stage of our river. And lastly, the last diagram is the lower course, or often referred to as the old age stage. So those are just some names that they are given. Okay, it's up to you as to which of those you prefer to use. You're either going to use upper, middle, or lower, or youthful stage, mature stage, or old age stage. Okay. Then it says, B, along which one of the three courses, R, S, or T, is flooding most likely to occur? And if we look at the diagrams, you will notice that diagram T has got an extended floodplain, and therefore flooding is most likely going to take place within that section of the river. 4.2c. Explain how the characteristics of the river course mentioned in 4.2b will promote flooding here. So why essentially is flooding going to take place in this part of the river? Number one, you will notice that it's got an incredibly gentle gradient. Because it's got the gentle gradient, the river water slows down and it will have time to overflow its banks, which are not very high in the last section of our river. And I already pointed out that it's got an exceptionally wide floodplain, which allows the water to spread easily within that section. You've got lots of deposition taking place in this course of the river, which causes that riverbed to become shallower, therefore less space within the river channel, which will encourage flooding. And also it's the final stage of our river, you've got a large volume of water that has been collected from all the previous tributaries upstream. So there's once again a variety of different answers that you can answer for that specific question. 4.2d. Flooding along the river course named in question 4.2b can be both a blessing and a curse for the people living on the adjacent floodplain. Explain the statement. If you look at the mark allocation, it's 2 times 2, and in the question they've asked you specifically for a blessing, so that is something that is good, and a curse, which is obviously something that is not as good. So for the blessing, if we have flooding taking place, fertile soil or silt is deposited on the banks or on the floodplain of that river, which is good for agricultural purposes. So that is a blessing if a river were to flood. Okay. On the other hand, a negative consequence or a curse of flooding is flooding can cause a lot of damage. Previously in a question, we spoke about how it causes loss of life and loss of property if people have built along the banks of that river. So not only can flooding be good, it can also have its negative consequences. 4.2e. State one method that can be introduced to reduce flooding along the course. So always in geography grade 12s, we are given problems and you are always asked to provide solutions to these problems. Some things that can be done is that we could possibly raise the banks of the river in that final stage using what are called levees. Okay, so we make these levees, which raises the sides of the banks and lessens the chance of flooding in that area. Furthermore, you could plant vegetation. That vegetation would absorb a lot of the water and reduce the amount of flooding. Furthermore, we could put or build a dam which would absorb a lot of that water upstream so that less water would get to that point of the river. And there are many different ways. You need to just decide on one. Okay. All right. Once again, question 5 is a true or false question. Okay. We've been given a diagram showing the water table during the wet season, which is indicated by this broken up zigzag line, and we are shown the permanent water table, whether it's the wet season or the dry season. We are given different true or false questions that we need to answer. These are based on the different types of streams that are found on the Earth's surface. So if we look at the first question, 5.1, it says River X will only flow after a heavy thunderstorm. Now if we look at the position of River X over there, it doesn't touch either the wet season water table nor the permanent water table, and therefore it is considered to be what we call an episodic river. Okay? Now, an episodic river will only flow after a heavy thunderstorm, which makes this statement true. Okay, so episodic does not rely on groundwater during the wet season or the dry season. It purely relies on a period of rain for a short period of time, and then that river dries up altogether. 5.2 says, River Y is a periodic river. I've said to you before, another name for periodic is what we call a perennial river. Okay, it only flows during a specific season. So if we go and look at the diagram, there you will see is River Y, and you will notice that it's only intercepting the water table during the wet season, which means it relies on rainfall for a specific season, making this statement true. 5.3. River Z will only flow during the wet season. Now if we go up to the diagram, there's River Z. You will notice that the wet season water table flows through it, as well as the normal permanent water table. So the answer to 5.3 is essentially false. It will flow throughout the entire year. 5.4. The water table lies at a lower level during a prolonged period of drought. The answer to that is true. If we have droughts taking over, which is a shortage of water, the water table level drops because there's nothing to replenish the level of that water table. The last question, River Z does not receive any water from base flow to support its flow, and you will notice that it does receive this addition of water, and so this statement for the last question is actually false. Once again, those are easier sort of questions that you should be able to get easy marks from them. Okay, now question 6 is testing our knowledge of drainage patterns, the types of streams that are found in them, and looking at our different types of flow hydrographs. So it says here, refer to figure 6.4 HF, representing the drainage basins of 2 river systems A and B, and flow hydrograph C to F to show runoff in rivers after rain. Also read the extract on floods below. Okay, so you will see that we've got 2 drainage basins, obviously of a different shape. Below those 2 drainage basins, we have been given 4 hydrographs. Underneath the hydrographs, it speaks about flooding. And like I said to you before, you need to read the information that's given to you, highlight important key concepts, and use that information to answer the questions that follow. Flooding occurs when water overflows its normal channels, such as streams and stormwater drains. There they're just giving us a definition for flooding. Floods may also occur when there is an accumulation of water by drainage into areas which are not normally submerged. Floods are common in South Africa following long periods of drought, overgrazing, and the deterioration of the land makes the ecosystems vulnerable. Humans can alter the flow characteristics of a river negatively by clearing vegetation, constructing impermeable tar and concrete surfaces, and building on the river's floodplains. So let's go and look at the questions now. The first question is to define the following terms. The first term, question A, is to give a definition of a drainage basin. And we've spoken about this before. The drainage basin is the total area that is drained by the main river and its tributaries. So that is our drainage basin. Total area drained by the main river and all of its tributaries. I often find that if you draw a little diagram, you can explain your points a lot better. So there would be your main river, and there would be all your tributaries to go with your definition, as where you say that it's the total area that's drained by the main river and our tributaries. Then they want for 6.1b a definition of a river system, okay? And what the river system essentially is our main river and its tributaries. So the river system is found within the drainage basin. So if you specifically going to go into more detail, the river system refers to the main river and its tributaries. Right. Describe the shapes of the drainage basins A and B respectively. If we go back to the figure, you will see that drainage basin A is circular in nature and drainage basin B is elongated. So the 2 words that they are looking for, sorry, let's just go back. A is what we call a circular drainage basin, and B is what we call elongated, or often an elongated basin can also be referred to as a longitudinal basin. Okay, grade 12, so that brings us to the conclusion of our questions and our answers. We hope that these have been useful in helping you to understand rivers and their job on the Earth's surface. There are still another 2 geomorphology sessions to follow this one, so we hope you will stay tuned and watch those as well. Thank you.